So yesterday we learned a shortcut or a new method for proving that two triangles are congruent. It was called the side-side-side triangle congruence postulate. And I like to highlight those so they stand out to me when I'm taking a quiz or something. And we had two main reasons or properties that we would use when we did what I called adding our brain to the picture. And one was the reflexive property that basically just said a side is a side. So it's when we say side DB is the same as side DB because they butt up against each other or are shared. The other one was our definition of a midpoint. If something's a midpoint, well, let's make that. It's in the middle. So if one length to the left of it is 3, then to the right of it is also 3. So when they tell us stuff is a midpoint, they're basically doing that so we can steal some sides for free. Same with the reflexive. When they're butting up against each other, it means we're supposed to say steal that side for free. And you can look at examples of that from yesterday. So now we're going to have a new way. It's called side included angle side, which we're going to call side included angle side. The key word is this included angle. You have to make sure that when you walk, you don't lift your pencil. So I always hop on a road. I travel through this angle to the other road. This would be called side included angle side. Notice I didn't lift my pencil. If my other side was over here and I didn't lift my pencil, I'd say side, side, angle. I have to say side, angle, side when I don't lift my pencil. So when I write a congruent statement, I would say that triangle A, B, C, and I could have done that in any order. But once I pick my first order, it locks in the second order. So let's erase this and suppose we had to fill it in. We would say who has a single arc in it? R does. Okay, what road are we traveling here? Okay, A to B is this one. So I'd have to go R to S along the road with a single dash and then Q. And that is by side angle side, our new postulate. So now we have two shortcuts, side, 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 get all three matching pairs and no angles. And now if we can get this a pair of sides with the angle smashed between them, that's enough as well. So here's an animation for that. You'll notice that I have a pair of sides with single dashes, a pair of sides marked congruent with double dashes, and when I walk from one to the other, I travel through angle A, and that's the included angle. So that's enough for us to stop. Those will match perfectly, and we have enough information to say they're congruent by side, angle smash between them, side. So when you're asked what additional piece of information would you need, you have to digest what information you're given. So let's go select our line tool. We are given a pair of sides, these short ones, AC and LM, as being congruent. So I'm going to slash through that. What else are we being given the same? So I'm going to grab my line tool again, and it looks like I've got an angle the same. So the only thing I need to get or be told is that the side on the other side of the angle is the same. So I travel from A to C through the angle without lifting my pencil. I'd have to go C to B. So I would have to know that CB is congruent to, and let's put it in the same order. I don't know why it goes so big on that second one. Let's knock it down to 18. But C to B would be the same as, again, go to match your parts. C goes with M. Look at the single arc in there. And B goes with K. We would need to be told that this long side is the same as this long side, so we can walk side, angle side without lifting our pencil. If we had this other pair over here, we'd go side, side, angle without lifting our pencil. So that's kind of important. What information do I need over here? Well, let's remove these for a second and let's go see what we were given. Looks like we're given a pair of angles the same in there with a single red arc. So I'm going to cross the angle off. What can my brain add to the picture? This is a dead ringer for our reflexive property that LB is exactly the same as BL technically, but I won't mark it wrong if you write LB. So now I've got another pair of sides that my brain added to the picture. So now let's walk a triangle. LB through the angle, and I'd have to, without lifting my pencil, I'd go LB, that's one of the sides, through the included angle, and the other side would have to be BN. Okay, so I would need BN to be the same as LE. All right, and I should technically Command copy, Command paste, and put the bars over, and that should be a congruent sign. But the time spent doing that isn't, well, now I have to do it. Command copy, Command paste. You don't need to do it though. Just know that you have to be told that the top and the bottom are the same as well in order for you to get side, included angle, side. And I can't even get that one to go on there nicely. So let's move on to our next page. It says, again, there are many reasons, properties we use to justify some unmarked angles being congruent. I call that add your brain. Okay, they're not marked, but you should know they're the same, and then you have to supply the reason. Okay, so let's go up here. One very common one is vertical angles. So there's a couple pieces of information marked on here. AX is marked or given as being the same as CX. These little runners mean that the lines are parallel. What else can I steal? Well, if I knew X was a midpoint, I could get BD and XD if they told me, but they didn't tell me that. I see an X in there, and I see my vertical angle pair right here. So I know, whoops, why isn't it marking it? Let me grab one. Command copy, Command paste. I wanted to drag that thing up into that angle. Is it not going to allow me to do it in here at X? Yeah, there we go. And do that. Actually, let's just do it right on here. Command copy, Command paste. And let's go put it over here just to give you the visual. Those purple dotted angles, BXA and DXC, are also congruent by a vertical angle theorem. So that X is a really good trigger. Now we're going to have a new one. From last chapter, we knew that if two parallel lines, look at the trigger for that, there's these little runners on here. That means AB will never cross or runs parallel to DC. I know that parallel lines cut by a transversal make alternate interior angles the same measure. So that blue one and that one, this one, and this one are the same by the alternate interior angle theorem. So let's go put that on here. So we have angle up at the top, A, B, X is congruent to angle. Now let's match our parts. I started with A, that goes with C, and then X, and then D. You make the next statement for the purple ones. So pause the video and you type that in yourself. The purple ones would be BAX congruent to DXC. And what's our new reason? It's not new, it's an oldie, but it's new to this chapter. That should be an angle sign right there. BAX, and then angle D. Sorry, this one got mixed up. So let's fix that. So BAX, the same as DCX, DCX. Now we're good. All right, what's our reason? The alternate interior angle theorem. Or you can write alternate interior angles are congruent. At this point, we would stop and go practice on some of the odds here, and then we'd come back and we would revisit our proof reasons in workflow before we practice on a couple proofs. So let's go open up our proofs reasons I think I closed that, so I'm going to go open mine up here and revisit what we have in our workflow and our reasons. Sorry, I didn't have that ready to roll. I'm slowing us down. So that's on here. So again, we have our big ones highlighted. If you need to add to this, but we just did alternate interior angle theorem, and that says that alternate interior angles are congruent. Alt int angles are congruent. We probably don't need that highlighted, and we probably should go in another color. And they're not congruent, they're congruent. Vertical angle, we already put on there that those are congruent. We've got a reflexive, that when they share a side or share an angle, we're going to add that. We know our side, side, side. We can beef that up later. But our workflow is what I want to discuss. We always rewrite the given. Okay? So anything that's marked and was given to us, we rewrite it. And then we add our brain. All right, let's go highlight that. I always have been highlighting that in yellow. That's when stuff isn't marked, but for the reasons given above, you get to state that you've got congruent parts. Okay, all these reasons, if they're butting up against each other, we probably have a side we can steal. If we have parallel runners, we're probably going to have some alternate interior. If we see that X, the angles across from each other, probably a little vertical angles. This next step, all right, we then need to decide if we're getting triangles congruent, like full triangles congruent. Let's go highlight that. I'm going to do it in pink. Or if we're getting the parts of the triangles congruent, like just the sides or the angles. That's on hold till section 4.4. But if we're getting triangles congruent, right now we know we're going to end in side, side, side. Or our second shortcut was side included angle side. In 4.3, we're going to have two more, and then we'll have a third later on in the chapter. But this is what you should be comfortable with now. I rewrite the given. I add my brain using the reasons above to get unmarked parts, enough so that I can stop and have three sides the same, or two sides and the angle smashed between them. So here's our new proof right here that we're going to write. I'm going to take these off. I made the video before and I'd put those on. So I'm going to take those off. I'm going to take these off, and you should as well. I already, okay, so let's yank those off of there. These are all our little pieces we're going to use on our proof. So what's the first thing we do in our workflow? We rewrite the given, okay? So we would grab this X is the midpoint, and we would rewrite it down here. Okay, so let's hop on there. Why isn't it allowing me to? I'm going to just grab a new text tool. You can as well. Okay, and we would say X is the midpoint of AG and NR. Why? Because it was given. Next up, by definition of a midpoint, it says X is in the middle of AG and X is in the middle of NR. So here's what I know. I know that since X is in the middle of NR, NX right here is exactly the same as NR right here. It's what it means to be in the middle. I can make another statement though because of that as well. So put your cursor right here and you make another one. It also said X is in the middle of AG. So what do you get to say? And you get to say that from A to X is the exact same distance as from G to X, also known as AX is congruent to GX, for the same reason. So I'm going to stop and I'm going to go on the side over here and see what my brain's been adding to the picture, because my given didn't really give me any sides or angles. But the fact that X was a midpoint gave me, and I like this font, and I like to do it bigger, it gave me a side and another side. So now I know from my workflow that I need to end in either side, 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 or side included angle side. So my brain's got to kick in again, and I have to ask myself, do I know that AN, the other side, is the same as RG, this other side? And the answer is no. I knew from definition of a midpoint that I had two pairs of congruent sides, the ones with the single dashes and the ones with the double dashes. But there's no way of getting the third side, so I know I have to go side angle side. Notice how my logic is working. So why do I know in here at the X, for one of our reasons, what reason up here is when we have the X and the ones across from it, and it's our vertical angle theorem, that vertical angles are congruent. So let's hop on here and state why these two angles are the same. Should be a congruent symbol. That's by our good friend VAT. How do we always end? We walk ourselves to what we were supposed to prove, that triangle ANX is exactly the same or congruent to triangle, and I should put the symbol in there, and I did in class and will in class, but for these notes that I'm videoing ahead of time, I forgot to add that on there. So, and what's my reason? Is it SSS? Nope, I couldn't get those sides, third pair, the same, but I was able to get the included angle with a little vertical angle theorem. So now, what we did next was one more proof. So here's some observations. Okay, the parallel lines with those little runners, parallel means I will most likely use alternate interior angle theorem, sometimes cap. Also, because I have a side and another side, you might say, what's the other one? XZ is itself, little butting up against each other, some reflexive. And I'm going to have alternate interior. I know I'm going to be getting side angle side. So this is kind of what I'm observing as I look at the picture. So let's start our proof. We grab the given and we put it in for the reason of given. Okay, what's our next statement going to be? I'm going to tell you, I think we should see that those are butting up against each other, and that from X to Z is itself. Technically, we should command copy, command paste, put the bar over the top, put the bar over the top, and that equals should be a congruent symbol. Okay, now what was the reason for that? It's an oldie but a goodie. You should type it in right over here. When it butts up against each other, we say it's the reflexive property. You could just write reflexive. Now, our new one, not new, our new old one. It looks like I spelled reflexive wrong. Let's go fix that. Reflexive. All right. Why is angle WXZ with the pink dot the same as down here YZX? And it's because they're alternate interior angles. And you can write alternate int, you can go like this, alt int angles, or you can write alternate interior angle theorem. Either one is fine. So now the very end, notice I'm ending with what it says I'm supposed to. I'm supposed to prove that the triangles are congruent, and I only have two reasons, either SSS, where all three pairs of matching sides are the same, or what we got, side, angle smash between them, side. So side, angle, side is our winner. All right, the next thing we're going to do is go back and do a couple odds on 4.2b. We're going to end the hour with a formative quiz in a Google form. Okay, just 2 or 3 questions just to see if you've got the main gist of our side, 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 and side angle side down. And you can use your notes on it too. All right, have a good one.